Going to be solving array problem number 1, which is find the element that appears once in a sorted array where all other elements appear twice, one after another. Find the element in O log of n complexity. So the inputs are up here, and we're looking for 4. I did some preliminary work to make it a little bit easier for me and just for the video. So what we're going to do, I'm doing a binary search in which we create a left pointer that's going to, between the left and the right pointer, it's going to determine in which direction we go of the search. So in this case, what I realized was that the pattern goes from every even number, the one after it should be a pair. If it's not, then we need to go in the direction that is causing the issue. So in this case, for example, we get 0 and 1, index 0 is 1, index 1 of element 1, these two are a pair, then 2 and 3 are a pair, and then 4 is the issue. So I took the left pointer, set it equal to 1, the right pointer equal to the array length minus 1, and then the middle, this is just for example, but I know middle wouldn't be right there, and then the left plus the right divided by 2, floor, so this way. In this case, if I were to have 11 divided by 2, I get 5.5, but with the floor I get 5. So what I'm going to do is set it up with while left is less than or equal to R, mid is equal to left plus right divided by 2, floor, and what we're in the first part is we're going to determine if it's equal to 1 based on modulus. So we're going to take the middle divided by 2, and if the remainder is equal to 1, what we're going to do is we're going to compare if the number, the array at the middle, essentially this one right here, 5, is equal to the array at the middle minus 1. So essentially we're comparing this one with that one to determine the direction, because at this point we already know that we're going to update our pointer, this one, to go this way. We just need to update it to see where the pointer is at, because if this one was like a 6 and this was a 5, then we know we need to update our right pointer not to this one but to the one over here. But since we know that this one's incorrect, so it's not equal, it's not an else, we're gonna do an else for it. So in this case, if it was correct, we would update the left okay. To rephrase this, so if array, the element at the middle array is not equal to the array at the middle minus 1, which essentially is this equal to this, and no it's not, what we need to do is update the pointer, the right pointer, and set it equal to the mid minus 1. So this is that, like I was saying earlier, states that we're updating this middle or this right pointer to not only be at the middle but subtract it to 1, because we understand that this number hasn't been checked and potentially this one over here could be a 4. Else we would update the left to be the middle plus 1. So we would if that was correct, we at that point would understand that, let's say it was 5 and 5 and 6, we would understand that these two are correct and that the issue is more ahead. It's on the right side of the issue. So we would update the left pointer to go to the right, and we wouldn't just update 1, we would update it to this one, because in this scenario 4 would have been correct. Okay, so now that we got that one, but like I said, in our case, we know we're updating the right equal to the middle. So here to help me out, I created this one. So I'm updating the left is still equal to 0. The right is now equal to mid plus 1. So that's equal to mid earlier was 5. So now it's 5 plus 1, which is equal to 6. And then the middle is equal again to left plus right divided by 2, which is 3. Sorry, typo in there, so it's 6 minus 1. Because we met the condition of if array mid, we met this condition, so we set the right equal to mid minus 1. So that's actually going to make it a 4. And this one a 2. So just to update these values over here to make it a little bit cleaner. 0, 4, and 2. So I rewrote these to keep the constant left, middle, right? So middle would be 5 minus 1 would be, sorry, right would be 5 minus 1, which is equal to 4, and 5, so that would be 4 plus 0, which is equal to 4, divided by 2, which is equal to 2, and then 0. So our new values are 2, 4, 2, 4, and 2. And then at this point we have this part of the array, which is which is 1, 1, 3, 3, and 4. We would set our new pointer, so it's left, middle, and right. And then we would continue back with our information here. So now that we've completed the else, we will need to also do the else down here. We completed the if is equal to that. So now else, which would be the equivalent of, since it's not equal to 1 here, technically we could do else if. It would be mid divided by 2 is equal to 0. Then this is what the else is giving us. So in our case, it would be if, if array of mid is equal to array of mid plus 1. So in this case, like I mentioned earlier, what we're comparing is, since we said that 0, 1, 2, 3, 4, since we said every 2 is a pair, right now what we're comparing is that if the mid, which is 2 right now, which is 0, 1, 2, is equal to this one here. So we're saying if those two values are true, what we want to do, because at that point we determined the two values beforehand, which is 0 and 1, are also a pair. That means we remove the left pointer instead of equal to the mid plus 2, because we're going from 2, 3, 4, because we already know that these two are accurate. Plus 2. Else we would set the right and update the mid. -2. Sorry, -1. Because at that point, if we would determine if the one in the front is not correct, that means that the issue is on the left side, that we still haven't gone small enough to determine which side it's on. So this would give me the other solution on there. And going back over here, we would update again our values, which would be left, middle, right. Like we said, left is gonna update from 0 to 4 because it's mid plus 2, which is beforehand was 2, so that's 2 plus 2 is equal 4. Mid is going to be calculating a bit, and then right still stays the same. So we do right plus left divided by 2, which is 4 and 4, which is equal 4. And here the last thing I need to do is set a return statement that if return mid, if array of mid, array of left is equal to array at position R. Array at position L is equal to array at position L. Return that. Since we're doing a Ruby markup, I had to do mid at the end so I can return what's left. And mid would give us, based off of this, would give us that the index at 4 is our solution.